Hi guys, and welcome to a new tutorial video. Today we are going to be making a platformer controller for a simple platforming game. Let's get into it. Alright, here we have the basic default Unity screen. We're going to start out by creating a 2D sprite. In this case, I'm going to be using square, but you can use whatever your player sprite is going to be. And I'm going to name it player. We want to reset the transform so it's in the center. Here, my player's a bit too big, so we're going to scale him down a bit, like so. And I want to set his color to be something darker. Then we are going to add a box collider 2D so we can do collisions, and a rigid body 2D for physics. And finally, add in a script called player movement, and this will control our basic movement. Alright, now we are going to want to also go down here and create a 2D sprite square, reset its position, move it down, out, make it a little thinner, and we are going to call this ground. And for later in the video, this is going to need to be on the ground layer. There is our ground sprite. Now we're going to go into our player movement script, open this up in whatever editing solution you would like. In this case, I'm using Visual Studio. And we're going to get into the basics of the coding. So first up, we don't need these comments. We're going to need a private rigid body 2D, call it RB. And then we're also going to need a few serialized fields. And this will be for our acceleration, for our max speed, and finally, for our linear drag. So in the start function, we're going to get the component of our rigid body 2D. Then in our update method, well, there's one more variable we need to do, private float movement, or we can call it horiz movement. And that will control our horizontal input. So horiz movement will equal input dot get button down jump, and that will be, or not jump, sorry, input dot get axis raw horizontal. There we go. Then we're also going to go into our fixed update and do the basic movement. So we want to add a force of vector2.right times our horizontal movement times our acceleration. Then if our the absolute value of our x velocity is greater than our max speed, meaning we're going too fast, then we want to simply cap our max speed. So we'll go into here and say rb.velocity equals new vector2, and then we're going to use some fancy code here, mathf.sign, which returns either -1 or 1 depending on the sign of the float. and that you pass into it. We're going to use rb.velocity.x, and then multiply that by our max speed, and then rb.velocity.y for our other variable in the vector too. Now we need to apply linear drag. So to do this, we can say if the mathf.absolute value of our horizontal movement is less than 0.4, meaning we don't really want to move anymore, then rb.linear drag, not is touching layers, dot drag, equals our linear drag. Otherwise, our drag is going to equal 0 because we don't want to have drag while we're moving, but we want to be able to slowly come to a stop. And then one more thing to just make this easier is we're going to add a variable called changing. We're going to say, or we are changing directions. And then up here for this is another cool thing that I find really nice and handy, is to go changing directions equals, and then if you put an arrow after it, then you can type out some kind of code. So if this is greater than 0 and rb.velocity.x is less than 0, then we're changing directions. Or just go ahead and copy this and switch the signs around. Like so. That means we're changing directions, and this will update every time we call update one reference, and that's where it's referenced. So now we have our basic horizontal movement. We can go back into Unity, go to our player, and set some basic values. So in this case, I'm gonna set these. This is just what I've found to work before. And then if we run it, you can see that our player has some nice, forgot to add a box collider to the ground. But if we run it, we can see that our game now has some nice smooth movement. You can tweak these values any way you'd like up the velocity or whatever you would like to do in order to make your movement as good as it can be, but free game. But that's the basic horizontal movement. Now we're gonna get on to the jump. The jump is pretty simple, but there are quite a few variables that we need to do. So let's first start by creating a new object under our player called ground checkpoint. Now if we zoom into our player, we can drag this to right where his feet are at. See, here's our player, and then there's where the ground checkpoint would be. Now if we go into our script, we can create a few more variables. First is a serialized field for a private float ground or jump force. Then we need a serialized field private float ground check radius. We're going to need a layer mask called ground layer. And finally, we are going to need a transform of our ground check point. And one more thing is a private bool on ground, like so. Now we can go into our update and here's where we're going to check if we're on the ground. So we can say on ground equals physics 2D dot overlap circle, and then we can just add in ground checkpoint dot position, ground check radius, and ground layer, those 3 variables. And there's our on ground variable. Now in our update function, we can say if our input dot get button down jump. So if we want to jump, then rb dot velocity dot equals a new vector2 rb.velocity.x and 0f. And so we want to cancel all movement downwards, and then we want to add a force of vector2.up times our jump force, and then we want to use force mode 2d.impulse just so it instantly applies that force instead of slowly applying it. And that is the basic jump. Here, if we play, we can see that for some reason, forgot to assign our values. So go ahead and do 12 for the jump force. Ground check radius, I'm gonna do 0.1. Ground layer will be the ground layer that I have assigned, and ground checkpoint will be this point. And actually, one more thing we can add to our code just to make this a little easier to see is to go on draw gizmos. We can set our color to be something like green, and we can draw a sphere at ground checkpoint, ground check radius. Make sure this is ground checkpoint dot position. Now, when we go into Unity, we can now see what our ground check is going to look like. So everything, if our player is touching the ground, that means that this sphere is touching this box. Now, if I play, we need to set this to be the ground layer. Now, if I play, you can see that when our player hits the ground, he can jump, but he can air jump, and that's because we need to go into here and say, are we on the ground? So if we jump and we are on the ground, then we can do the code. Then we can do the jumping code. So if we play, now you can see I can spam the spacebar as many times, but I can't jump in the air until I hit the ground, and that's when I can jump again. So we see a few problems with this. First up, while we're in the air, we don't have any air linear drag. The second is our player falls super slowly. So to fix the falling slowly, we can just go ahead and up the gravity scale and up the jump force, and okay, but we see a problem when we do a normal jump, he just jumps, but when we move while jumping, he goes much higher. So let's try and fix that. What we can do is add some air linear drag. So go private void, or what we can do is we can say if we are on the ground, do this, else we want to set our drag equal to air linear drag, which is a variable we haven't created yet. So let's go ahead and create that. It's going to be a float air linear drag. Now, when we go into our scene, we can set our air linear drag to like 2.5, and you can see if you keep your eyes selected on the player while he's in the air, he is 2.5, and you can see that now. Here's his normal jump. They're about the same. So, woo! Oh, and we can also freeze the rotation. But that is the basic platformer character. Hopefully you can get something out of this, tweak the values how you want, and then you can use this in your games. Well, thank you for watching, and subscribe. See you later.